Hello everyone, this is Telecom Christopher. It's very nice to see you again. And in today's episode, I would like to explain in detail about the VXLAN. Because just from my point of view, I think the VXLAN for warning scheme is a little bit abstract. Even though I use some concrete example in the daily life, it's a little bit hard to understand. But in order to know the network stuff, we have to take a look at the script. And in this episode, I would like to take Huawei's CloudEngine switches as an example. I think the Cisco are the same because they all comply with the same RFC. And for the Huawei product, they have the simulator which is called ENSP, Enterprise Network Simulator. Maybe that is the pro version, but I tried several times, whereas it is still failed. I know maybe there's something wrong with the software, especially the VirtualBox, which is simulate the Linux system of the switches. But today, I have copied all of the script here and will explain to you in detail. And as you can see on this slide, I list out some of the items and its identifiers. And in the LAN below, in the followed LAN, the switches is identified by its loopback addresses because the loopback address is never down. Or for example, 2.2.2.2, that is the loopback address. Every network element have a loopback address that never down. And then the next one is the OSPF. The OSPF, which is IGP. It will run in underlay network, which will make all of the switches IP reachable. In other words, the switches can talk with each other via the layer 3 because of the OSPF. And then the next one is the BGP. BGP is the Border Gateway Protocol, which is identified by its process ID. Maybe you can identify them as 100 or 200. And the BGP within the same AS, autonomous system, which is identified by the AS number, is called interior BGP. And between the AS, which is eBGP, exterior BGP. And the main function of the BGP is to exchange the routing table of each other within the same AS. And then the EVPN. EVPN is a sort of the VPN, Ethernet VPN, and here works as the control plane. And it is identified by the BD, which is the bridge domain. It's a great broadcast domain, one VXLAN network, and the VNI. As you can see, it will configured on the view of the VNI or the BD. So I said the EVPN is identified by the BD and VNI. And then the VRF, for the lamp of the distributed gateway, we will use the VNI. Another VNI, just the number, to identify the VRF, because the different subnet is separated by the different VRF, and the VRF is identified by some sort of number, and this number is called VNI. And then the VXLAN network, which is identified by the VNI, VXLAN network identifier, and the broadcast domain, which is identified by the bridge domain identifier. And so let's come to the LAMP for today. Today's LAMP is very easy. As you can see, the switch 1, 2, 3, VM1 and VM2 is in the same subnet, but belong to different VLAN, which is called VLAN A and VLAN B. VM1 want to talk to VM2 via a VXLAN tunnel. start from the switch 1 and ended at switch 3, which means the ingress point is switch 1 and egress point is switch 3. And then here, the switch 2. The switch 2 deliver the packet from the switch 1 to the switch 3 because this one is the fiber connected. And the switch 2 also has an important role which is called RR, route reflector, and we will configure it for the BGP VPN. It will resolve the N-square problem. So today's experiment is for the same subnet virtual machine communication via a VXLAN tunnel. This VXLAN tunnel is layer 2 VXLAN tunnel. As you can see here, the first code, as in my point, the laser point. Okay, the Huawei system view. The system view, which means to transit from the user view to the system view. After you type this code, you can configure the switch. In the system view, there are two types, two parameters. The first one is system view without any parameter. And the other one is a parameter which is called immediately, which means when you type it and then you type the enter, when you enter it, the command will be enabled immediately. But here, for best practice, I will use the system view without any parameter, because when I type one and then I can commit. This is the best way for me to roll back. Commit, which means save. So the system view, and then from the angle bracket, and then change to the square bracket with the name, sysname, SW1 for this one, switch 1. And then commit. Commit means save. And then for the switch 1, the interface loopback, configure its loopback. IP address to configure its IP address. Switch 1 loopback, for example, 2.2.2.2 or 3.3.3.3, and 24 with its mask. And then the quit. Quit means back to the previous, back to previous. And then to the switch 1, back to the switch 1. Previous folder. Switch 1 in the force, the port C1, the port C1, port C2, and port C3. It will run the OSPF to make each other IP reachable. So as you can see here, the interface port C1, the onto port switch, which means the port C1 is a layer 3 port, but normally in the switch all of the port works at layer 2. If we type the onto port switch, it will be changed to layer 3 view, and then IP address, the port C1, and then quit. So for this code will be copied in the switch 1, switch 2, and switch 3. We just configure the IP address and loopback address of each other, C1, C2, C3. And then we will run the OSPF. This is the ITP. You can run ISIS also, or you can even run the eBGP. That is the best practice for the spy leaf architecture. Area 0, which means this is the backbone area. All of them, ports C1, C2, C3 is in the same area. Network, which means announcement. It will announce which subnet I have. For this one is the networks. Switch 1's loopback, and then the network port C1, and then the quit, and save. Okay. In this step, the underlay network is enabled. The switch 1, port C, switch 1, switch 2, and switch 3 can talk with each other via the underlay network. And then for the next step, as you can see, we will configure our VXLAN network. VXLAN network, which is for some type of sort of the overlay network. And then as you can see, the switch 1 accessing point, the port A1. The port A1 will now the VLAN A to transmit it via the VXLAN tunnel, as you can see, the bridge domain 20, which means this big layer 2 network is called 20, bridge domain 20, and then quit, and this bridge domain is enabled. Interface port A1 mode layer 2. Encapsulation .1Q VLAN A. And here the encapsulation, because of the VLAN has several encapsulations such as Q-in-Q, .1Q, and the tag or untag several types, and you configure here encapsulation, different encapsulation way. And then the bridge domain, and attach them to the bridge domain 20, and then quit, and then save. So this one will be enabled, will be configured on the switch 1 and 3, because the VXLAN tunnel will be established between them. And then here is enable BGP EVPN control plane. The control plane will be enabled. Okay. With the help of the BGP EVPN, it will establish the VXLAN tunnel automatically via the code EVPN overlay enable, and then the save. And then let's take a look at how the control plane will be configured. The first thing is we will configure the switch 2 as the route reflector server, and then switch 1 and switch 3 will be the route reflector client. Any update it will be delivered will be mirrored to the other switch. For example, any update from the switch 1, and then it will deliver those update to the switch 2, and the switch 2 will deliver to the switch 3. For this small scale network, it looks a little bit tedious and boring if you configure the route reflector, but if it is a large network, it will save you leg and arms definitely. So as you can see, we configure the switch 2 and server, our server here, the BGP 100. Because BGP EVPN, definitely we will run the BGP. Okay, BGP protocol enabled, BGP and its process number 100. And then the peer, SW1, SW3, we are in the same autonomous system 100. And then the collect interfaces, loopback. And then this means the switch 2 will collect with the switch 1 and the switch 3 via its loopback. It will never die. If you plug out the electronic, plug out its power supply, it will die definitely. And then L2 VPN family EVPN. For this code, it means it will deliver the EVPN package between each other. L2 VPN family, that definitely EVPN is Ethernet VPN is definitely the L2 VPN. And then the peer SW1 enable, enable this selection. Enable this session, the peer SW1 reflect client, The switch 2 is the server, and then this one is the client. Switch 3 is the same client. And then undo policy VPN target. For this script, which means it will accept the label stacked and routing every update from switch 1 into switch 3. If you do not undo this one, policy VPN target, which means it will filter all of the received routing, received routes. And some of them you cannot hurt because of the VPN target, because if it is not matched, it will drop that entry. So you undo it. It will accept every update and announcement from its client. And then the R server will mirror those updates to all of its clients, except the ingress one, if it comes from the switch 1 to switch 3. Okay. And then here we can see the configure the switch 2 as R for the BGP VPN control plane. And then after configure the switch 2, we will configure on the switch 1 and 3. it will pairing with switch 2, because in the data communication we all know that we will configure the inbound and also the outbound. The inbound and outbound is successfully configured, and then it will communicate with each other. So don't forget to configure the inbound. So the BGP 100, the same process, and then the same autonomous system number, and then pair SW2. We will configure the SW3 the same, switch 3 the same one, and then commit, save. So after that, we will configure the most important thing, the BGP EVPN instance, which is similar to a VRF because it has the route distinguishers and the VPN target. Now let's take a look at those scripts 9 by 9. The bridge domain 20, which means this VXLAN, this big layer 2 network. VXLAN VNI 5020. This is the VXLAN to connect the switch 1 and the switch 3. And here, it makes me a little bit confused. Why the bridge domain will be configured 20 here and the VXLAN VNI is different? Just from my understanding, I think the bridge domain is a big concept. This one is called the stretched layer 2 network. The stretched layer 2 network may be composed by several, 1,000 segments of the VXLAN or some other type of layer 2 tunnel. So as see here specified, that is a VXLAN tunnel, VNI 5020 here. And then the EVPN will be enabled, which will create a EVPN instance. And then you see the route distinguisher, which makes the routes propagation unique as distinguished from each other. And then the VPN target, they will say which route I will accept and which route I will be dropped. And then quit, commit, save. I strongly recommend you guys to use the two phases system view because it will help you to roll back. If you use the system view immediately, when you click the enter, it will enable it immediately. You cannot roll back. So use this one. Don't forget it. Don't forget about save. Okay, and then this one is the ingress head and point configuration. For this step, that is a routine step when you configure the VXLAN, because when you encounter the bomb packet, which means the broadcast, the unknown, the multicast. For the broadcast and unknown, it will, for example, and the ingress, the tunnel ingress VTAP, it will deliver this packet to all of its peers in the same tunnel, in the same VXLAN. So we will configure that. Interface NVE1 because the NVE is normally is a switch, and the source 2.2.2.2 here is to make it easy to understand. I will change the source into SW1, and then you will see from the SW1 with the VNI, which means the VXLAN tunnel head and the peer list protocol BGP, which is BGP means those tunnel is established by the BGP EVPN, and then quit and commit. If the SW1 has several, or other words, if the VXLAN 5020 has several switches involved, you will configure it the head and the peer list. For example, if you have switch 2, switch 4 or 5, you will specify its IP address here. And then finally, you will see that list of VXLAN tunnel has been established. So in today's episode, that is a very easy scenario. I just mentioned how to configure the VXLAN tunnel via Huawei's CloudEngine switches. Just the 5 steps. It's a little bit complex. because you will type several those long and tedious script, but that is the routine work. Each of the switch the same, so don't worry about that. You will have some because the CloudEngine switches support some of the automatically provision tools. I can't remember the names, but it definitely support that because this switch is the Linux kernel, and then it has the APIs for the others for the other tools to be invoked. Okay, and now this is the end of today's episode. Thank you very much. I will try to debug my ENSP, and I will try my best to show you on the simulator. Thanks everyone. Thank you for watching.